All right, everyone, thank you so much for joining. We're really excited for today's webinar. Today, we're going to introduce a new integration tool that's now GA in Redis software, and you're going to hear about how it can help you bring more data into Redis. So today, we're going to be covering, first, we're just going to introduce our new tool, which is called RDI, cover the business value that it brings and how it helps to integrate data into Redis much faster and much easier. We're going to have an actual demo of RDI, so you'll get to see it in action. And then we're going to have a great customer story with Axis Bank, who is actually using RDI, and you'll hear about how they were able to adopt it and all of the business value that it brought them. And then, of course, at the end, we will have time for question and answer. So today, you'll be hearing from me. I'm a product marketing manager here at Redis. I worked on the RDI launch, and I'll be joined by my colleagues, Yaron, why don't you introduce yourself, please?
Hi, I'm Yaron Parasol. I'm the Senior Principal Product Manager here in Redis, responsible for Redis Data Integration.
Hi everyone, I'm Niket Tushi. I'm a solution architect at Redis and I work closely with all the BFSI sector in India.
Great, thank you guys. So now let's dive in a little bit into the content. So we're going to start with what is Redis Data Integration. So it's no surprise that speed matters. I mean, whatever your industry, there are many use cases that demand speed. If you have a retail app that's not fast, you can't power fast shopping experiences that help you sell more product or provide accurate inventory and cart data. Or maybe if you're in finance, you can't power instant and accurate banking applications or provide relevant and fast data to your trading platform. And these are just a couple examples from a few key industries. There are really hundreds of use cases across dozens of industries that are completely dependent on your app's ability to be fast. But being fast is not easy. Your tech stack has likely been built using relational databases that are needed as a system of record, but they're just too slow. And that's why there's Redis to speed things up, and that's why there's RDI to help you make your data faster. So these relational databases are often legacy components of your architecture, and they're often immovable because they are used to power a lot of your business and mission critical applications. So it's really not practical or feasible, for you to update or replatform them, and they really end up slowing you down. And this also means that in order to operate at scale, you often have to resort to expensive relational database read replicas, which can result in really excessive database licensing costs. So there's problems with performance and there's problems with cost. So in order to speed things up, caching into a fast technology like Redis makes a lot of sense. But in order to do that, you need to keep data in sync with Redis between your database and Redis. And this is often a really significant challenge, and as well as a large development effort. So you can use a cache aside pattern, but then you'll be dealing with stale data or cache misses, which can actually increase your overall system latency because data is often requested both from your cache and then again from your primary database. Or you can undergo the expensive and complex challenge to custom build a data pipeline to actually prefetch data for continuous synchronization between your database and your cache. But now you're faced with additional complexity because you need to operate and keep two data sources in sync. And if you wanted to buy a third-party data pipeline tool to do this for you, then that can also get really expensive. But so is dedicating time and resources to keep your data in sync on your own and to operate two data sources simultaneously. Well, not with RDI. That's where RDI comes in. So with RDI, fast scalable apps are now a possibility in many scenarios where they just used to be out of reach. It's now a lot easier to pair Redis's speed with an existing database and keep your data perfectly in sync. Because RDI provides a no-code out-of-the-box solution, you can actually rest assured that when you add the speed of Redis, you're not adding a lot of complexity or potential issues with data consistency or cache misses if you go with a cache aside pattern. You can now sync your data, seamlessly sync your data simply. And finally, you can stop using so many really expensive read replicas of your primary database, and you can save money by simply syncing data to Redis instead to actually cut costs. So at a high level, what does RDI do and how does it work behind the scenes? So what it does is it helps you to seamlessly configure and deploy data pipelines between databases and Redis without writing code. It captures, transforms, and ingests any changed data from a primary database into Redis. And this ensures that the primary database is changed. Let's say a new record is added or an existing record is updated. Those changes seamlessly flow through to Redis. And you can also seamlessly deploy, test, manage, and visualize your data pipelines in Redis Insight through our popular and easy-to-use GUI. So how it works at a high level, RDI initially populates Redis with data from your primary database to get the data in there. And then on an ongoing basis, a change data capture or CDC collector keeps track of any changes to the primary database. the RDI stream processor translates the changed data from its original format into the your preferred Redis data types. And then the data is actually ingested into Redis, and you now have fast data for your applications. As I just mentioned, you can manage and visualize your RDI data pipeline directly in Redis Insight. So in a few easy steps, you can configure, test, and deploy your data pipelines. And then on an ongoing basis, you can visualize and monitor your data to see it flow from your source database into Redis. RDI can ingest data from most popular relational databases. We support Oracle, MariaDB, PostgreSQL, Persona, ExtraDB, SQL Server, Google Cloud SQL, and Amazon RDS, and there's even more to come. And now I'm going to hand it off to Yaron, who's going to run through a demo of RDI.
Thank you, John. So as John said, RDI can help your business to make slow data into real-time data. And I'm going to show that with a demo that basically mimics a real-time scenario of real-time inventory. So there are many companies that still operate in a hybrid mode where they have physical stores and they have online shopping. And in the online shopping, customers can order something and collect it in the shop. However, if the stock in the shop is loaded into the central database several times a day as an ETL, the customer can find that the order that they made online cannot be really fulfilled. And that's really disappointing and can churn customers. So let's look at an example of that, how we took such a scenario and transform it with RDI. So in this example, I just took 3 tables, one showing the products, the other one showing the stores, and the third one showing the stock of the product in every store. And these are in a relational database. I will show it in a second. And I'll also explain how we simplify the data model using the RDI pipeline and how we ingested it into Redis. And I'll show it in action. Next slide, please. So as you could see, there were 3 tables, and the data was highly normalized, as it's often the case in relational databases. But for the application, it's much easier to ask for a product and get the stock in all the stores. So to do that, I did just exactly what John mentioned before. I don't need to code, I just use this YAML, right? So when the table product records come in, I write them into a product key in Redis. However, I also do something like a join, and I put inside the JSON in a nested path, I put all the stores from the store product table, and for each store I have the stock. So when I show it on the screen, and I can show it now in a minute in a web app that I created for this demo, you can see the stock in all the shops, like the user online would see if the inventory is real time. So let me share my screen now. So let's start actually with the relational database. I have a Postgres server here with DB fashion. That's the name of the database for the application. And you see 3 tables like I showed in the slide: product, store, and store product that has the stock in the different shops. And I also have here a small web application that is already reading this from Redis, because I already ingested the data from Postgres into Redis using the pipeline that I showed before. And you can already see that I can see a product, in this case, Reebok shoes, and I can see the stock in all the shops. Now, what I'm going to do, I'm going to show you the data in Redis Insight in Redis. So this is exactly what I explained. You can see here a product, and you can see the stores attribute, and you can see the different stores. And in the store, you can see the stock. Now, I'm going to go back to my database client. And here I'm going to update the stock into 4. And I'm going to run it. And when I go back to my web application, you can see that it immediately turned into 4. If I go into Redis Insight and I refresh here, you will see that the stock is indeed 4. So what we've seen here is a real demo of a use case that can be beneficial for a real business, making slow stock data that is stored in a relational database in many stores, in many databases, into a real-time inventory for the online shopping website. And now, let me hand it over to Niket, who will talk about a real-time success story of a customer.
Thanks, Yaron. I think that was a great demo, and you hit on the right problem statement that lots of the organizations are facing. So let's have a deep dive into the Axis Bank story, like how they are implementing RDA along with the Redis and how they have implemented or redesigned their mobile application, which actually revamped skyrocket satisfactions of the customers. So Axis Bank is a top Indian multinational banking and financial service sector, which comes under a top 5 banks in India in the private sector. It's based out of Mumbai. So the challenge which bank was going through was again majorly related to the digitalization of the banks. So in India, digitalization and digital India making journey is going on very high scale, and that's how customers are started using mobile banking, and a digital challenge very huge in nature. So issue which comes generally with the banks is that as banks are having multiple offline branches and customer can go to your branch and update the information, the issue was that when you updated data into the bank's branch, the data was not getting replicated quickly into the mobile banking related databases. And that's because of the underlying nature and underlying architecture of the primary relational database. Those were deployed and the responsiveness that is required to replicate the data. And that's where bank was started getting complaints from the user that we are updating the details into the bank, but when we go to the mobile bank application, we are not seeing those updates. And that's how they started getting lots of the customer complaints. So how Redis helped them to not only zero down the complaint, but also to improve the performance and the response time faster for their mobile banking application and as well as the API call, that is using RDI. So with RDI, we seamlessly integrated their underlying relational database where the updates were happening for the branch banking or a core banking related information. As and when data gets updated into that particular branch banking database, as Yaron has demonstrated in the demo, the data used to get replicated into Redis into appropriate key value data structures of the databases supported by the Redis. And on top of that, they were using the query search module that is provided by Redis. So once the data is available into the Redis, whenever user does a login onto the mobile banking application, based on the multiple querying capability, they can quickly fetch the data in front of them. And that's how we cut down the performance very great. So they were getting around 76% faster performance in comparison to what they were getting earlier with the relational databases as the underlying database. We cut down their customer complaints 100%. So now they are not getting any customer complaints that is related to the mobile banking application and data mismatch kind of thing. So let's say customer is now updating data into the branch banking. The data is getting updated in near real time to mobile applications. So once they update the data into branch bank and they check the status on the mobile banking application, staying in the branch itself, they get the real time data in front of them. And that's how the data replication was 4.2x5 faster in comparison to the underlying technologies of the relational data structures. And not only that, by using Redis, we also save the cost of storing the data in a various format and we optimize those data structures as well. And they saved around $82,000 in storing and optimizing the data structures. Because RDI not only just syncs your single data table into a Redis, but it also supports the joins. So as we know that in banks, our everything, all the data is related to the customer ID. And we might have a multiple products with the bank and any kind of a data update happens when a user goes and update their personal information or they may opt for a new product. So as and when data update happens, how RDI integrates is that it actually syncs all the tables where primary key and foreign key relationships are have been provided, and it creates a single nested JSON object that helps banks to create a single 360-degree view record of the customer and store that data into Redis. So that's how they are actually implementing not only Redis just using the RDA, but they are also implementing querying mechanism, and they are shrinking the data by optimizing our various modules. So now let's see what a bank says in his own words. So Mr. Rupesh Samant, who is a group head of retail and digital channel, this is what he is saying. And he is majorly embarking on the lines whereby leveraging Redis, they have achieved a rapid data retrieval, they improve the performance, elevated user experience, and enhance the stability for over 6 million daily active customer users. So that's a great number of active users which they are serving on a day-to-day basis and having a zero customer complaints for mobile banking responsiveness, not only on the responsiveness, but in terms of the correctness of the data itself. Now let's have a deep dive into the architecture, because most of the people will definitely have a question that I am having system running in my organization for a longer period of time. And how do I simply add Redis without impacting the underlying nature of the architecture? So that problem has been completely resolved by the RDI, because RDI gives you a capability where you can introduce Redis as a plug and play experience. So in this screen, which is shared in front of you, we are having both the architecture. On top, what you are seeing is the architecture before implementing Redis, where core banking systems writes used to happen directly on the primary database, and mobile banking application used to query the primary database for all the API calls, and users was getting data information in front of them on the user devices. Now, what are the challenges or what are the limitations with that architecture is that on the right hand side that you can see. So the response time which they were getting with relational databases were 170 millisecond, but that too limited with the scale. So as you know that they are serving more than 6 million active users on a day-to-day basis. So whenever at any given point in time, active user base used to go beyond 200 or 500, the response time used to get stuck. And that's where the problem comes. And even if you add multiple read replica copies of a relational database, it will not solve your performance improvement because your data and underlying data structure remains the same. So same query will get executed on multiple read and it will take the same amount of time to provide the response. But with Redis and RDI, how we have implemented that you can see in the below diagram, that Redis and RDI got implemented into the system. You can see that RDI syncs with the database on the left hand side in the relational database, and mobile banking user application directly start calling or reading data from the Redis. So that's how RDI helped them to move and convert all the data which they are having into the relational database into the Redis into a proper key value structure. And it's not just a simple transformation. So again, there is a transformation of converting a raw record data of a relational database into a key value pair, plus joining the records from multiple tables based on the primary key, foreign key, and creating the nested JSON object. And on top of that, they are also applying a filtering conditions. Like they are not taking all the records, they are filtering out the records which are not required to be there into Redis. Maybe a customer where account is inactive or account is disabled or customer wants to delete the account. So those kind of a filtering criteria are applied while replicating the data into Redis. And on top of that, dynamic column generation based on the calculation that to runtime has been done with the help of RDI. So RDI also helps them to filter out the records from relational database to Redis conversion and add a calculated field on the fly dynamically, that too without coding, while storing the data in Redis. And that's how they can provide data to their end users on the user devices via mobile banking and the Redis read calls. So when we see the performance which they are getting with the Redis, then it gives them a constant 40 millisecond of app response time, because Redis gives you a millisecond response for most of the data structures and the queries that you fire on Redis. When we discuss for scale, even if they get user count, active user count per second more than 200, 500 infinite, Redis is going to provide you the same performance. And let's say if a user base count goes very high and in future they would like to do a scale, then just by adding a new shard, they will get much more better performance, unlike adding a read replica into relational database with zero performance. So that's how we help Axis Bank to implement and revamp their full mobile banking application and zero down on the customer complaints. So if Axis Bank can do this, then why can't you do that? So it's like that. Any organization, if you want to provide a quick data and a real data, and that to a true data, whether it's a cache or as a primary database for a read application, RDI is a great feature for you where you can experience the plug and play kind of a mechanism without impacting your original product underlying architecture. Just introduce new service, sync the data into Redis, and start providing response to your applications. So that was on the success stories of the Axis Bank, like how they get benefited with the Redis and the RDI. So John, over to you.
Thanks so much, Niket. Yeah, I think the Axis Bank story is such an incredible testament to how you can use the simplicity that RDI brings to achieve all the business value and transformative impact that you get with the speed of Redis. So thanks so much for running us through that. If you guys want to learn anything more about RDI, there's a couple next steps you could take. We have a QR code on the left that you can scan. It'll open up the link to the RDI docs, the official product documentation, so that you guys can go ahead and learn more, explore and see if RDI might be a great fit for you. And if you're ready to get started and you want to speak to somebody from our sales team, I'd have a Redis expert contact you and dive in a little bit deeper. Scan the QR code to the right, open up the link, and somebody from the Redis team will reach out to you shortly so you can get the ball rolling. And now we want to open it up for Q&A so that we make sure that we have an opportunity to answer any of the questions that you guys might have.